His topic is utilizing flex sensor for evaluation of pancreas disease. So be patient and listen. Thank you.
Thank you. I'm a pleasure. I'm in the amazing we are all the two. Actually, now with the position this and allowing to live on for and the picture. Every day, every year, this many people watch in the chess, we win or chess more or and moving and so and that. Many things is so on for the research for in the MS, the economy and so the life of the whole people. There is in the water mainly accepting of everything the size, this is simplification by company, reflections and analog. We have designed a simple interface. See the pattern because standing within the size. The electronics component into the analog to the first robot sensor at the figure capture movement and fixes. The check motion in the check motion and in the patient this can effect and the local average the body and the rest when the people are in the rest shift more and it's two sign in the chest but sentence when in the sign and line. The sign have more on the engine depending the chest in the condition to we can take it to time for the check mode written by action. The check mode channel written include the frequency. Sometimes in frequency we using in the MG to the record the frequency and the amplitude. The frequency is between 2 the 4 and the Hz amplitude. Intel image will transform actions and the monitor by just one. This gets to the class into main group in the last access check mode filter and two in the monitor check mode and efficacy in the terror freeze. The problem attachment in the day we have to the consist in the Taiwan và receiving monitor is on the method typically well method of all the same component around what they are complete and destroy data records equal low most and to the in especially in the diagnostic in the hospital when we lost no more this and to the electronic and to log or when to the recorded data. Therefore, the aim of the decision in the design simple effects because it should be kept caption vision sign of the diagnostic where monitor patient check more the condition. Also smart, we can just smart robots design for our with the two flex bend the sensor into the finger to mix and window. As you can witness the first picture in the brown line frequency into the rest and the check mode and the business possible check mode and integration. When we should be using the sensor way and the records in the manager is compressed for and the charge by when it so we first and to the calculation. in the figure I show it to the way it's washed or enter the sometimes many the paper or the receipt we are using in the acceleration sensor to the case back calculator. Then actually the problem we introduce the system this we also this cases the equation in the context implement data recording if the load is not the sample form and to the preparation for the right notation. Therefore, in there, I'm into to design in the symbol effects for recorded CP, which we design a smart roll entry. The global width to the face and the band sensor on the figure. It's the list sensor shown in the globe. This is all the globe rehearsal in design in for the lab in the nose. In the freezer form within it in the pen as well, many people see. Yeah. And the figure design this is we design into the module in the modules is into the record and the store data. And then when the movement on the hand is contrast, we are the child, so into the alpha, beta, C. And alpha, we have to the point the hand, which is the B, beta is always to show that the sweet, and C, we are to the touch. Touch and the finger with the hand. In the data we have published into the students with the small angle with an theta C small into 445 lecture, but exists in the 495. In the figure box, we saw into that in the in the chapter of fact where we record the data in the show with the hand. In the figure box, for the data in the on file in the common monitor with the data two figures. Because we set in the loss in the figure because and when we moving in the check the moving of the finger, it is compressed. It is mainly the noisy when the data. Now it is the result. We in the physical life we have to the wounds and the answer rather than we in the 45 answer. In the song we have to do the wound and the check and the angel. Yeah, in the word when we say that and after later we and fusion is in the frequency width and the balance amplifies and green movie the finger. And we in the range we try 11 we have to the volts and the place when it goes to the data is small. It is in the slide we direct to small than 19.8. Okay. On the also when trans in the result data in the when we case the change in audible over time is this the gap. And when the finger has in the first division, the bone change in the identification, then small we say that when we the the small wheels and the finger thumbs. Say is the motor action and finger mover. The motor that when we fish in the cabin, the wall under synchronization chain small interactions. This big ball can be utilized for the because with the Parkinson DC additional we this kept the fixing and everything early time. I think it's early time in the past. This when in the future we have to come back within the machine learning to the test in on the class and class 4 and it's the channel of the bigger DC. Thank you.
कोशिश भी कर, उम्मीद भी रख, रास्ता भी चुन, फिर उसके बाद थोड़ा मुकद्दर तलाश कर. Thank you, sir. Assalamu alaikum. Very good afternoon. Namaskar. Respected Dr. Tein, Vice Dean and Associate Professor, Pinaka University, Hanoi, Vietnam. Dr. Vijayendra Kumar Solani, Program Chair, RISE 2023, CMR Institute of Technology, Hyderabad. Professor Abdul Wahid, General Chair, RISE 2023, Dean, School of Technology and Director of CIT Manu. And Professor Pradeep Kumar, Convener, RISE 2023 and Head, Computer Science and Information Technology. Ladies and gentlemen, once again, good evening, good afternoon. A very warm greetings to each one of you. Welcome to the 8th International Conference on Research in Computing and Engineering 2023. I, Tunga Arundhati, host for this valedictory session on behalf of the organizing committee.
Yes, there's a little bit just. Can I? Please.
Now I would like to invite our keynote speaker, Dr. Tein, Hanoi University of Industry, Hanoi. Tein received bachelor's and master's degree in mechanical engineering from Hanoi University of Science and Technology, Hanoi Vietnam University in 2009 and 2012 respectively. In 2023, he has received PhD in robotics from Japan Advanced Institute of Technology from Japan with the Soft Haptics Lab, counted in an outstanding finalist under support from Japan's Ministry of Education, Culture, Sports, Science and Technology Scholarship. Dr. San received the Best System Paper Finalist Award in Robotics, Science and System 2023 and several awards in national competitions. He is a reviewer for many international conferences and journals such as IEEE Transactions on Robotics, IEEE Robotics and Automation Letters Advanced Robotics and SII. I welcome you, sir. Please give the keynote address on RISE 2023.
Good afternoon, everyone. being here today. Just a lot of people have asked in the year. Well, I'm so sorry that we come a little bit late, so you guys need to wait for a long time. But now we are here, and I hope that we can enjoy this keynote talk today. Thanks for your introduction. Today my keynote talk is talk about the two-word safety collision for UAVs. That is my very short introduction of mine, and mostly I focus on bio-inspired robotics and tactile sensing and perception. It means that I focus on the hardware mostly, so it's quite different with the topic of this conference today when people focus on the software and the intelligence. So today I would like to talk about my main talk has three parts: the introduction of UAV potential, the safety collision, the problem, and some current solution. And so in the last one, I will talk about the challenges and the future of UAV safety collision. Now, let's talk some about introduction of UAV. UAV stands for unmanned vehicles. So nowadays, such drones have benefited like in many fields from transportation to mining. It is a video just like in Japan. So you can see that the drone have used for agriculture. So it become more and more popular. So with the investment from big tech companies such as Fry from Amazon, Alphabet, Facebook, Microsoft, and FedEx, and finally IBM, drones still like have a bright future. However, every scene you have seen, every picture you have seen here is still like a ongoing future of UAV because of one reason. That is collision. So normally when drone is working, it has faced with so many problems, and especially when you see here the UAV can collide with the airplane. So here the human life have been challenged. Not only the UAV itself, the human life have been challenged. So it raised a question about the safety collision of drone. How the drone can collide with obstacle and keep the safety with itself and the other, the environment. So that leads to the safety collision problem and some current solution. Let's see how people and researchers have dealt with this problem. So normally it's a drone, and it needs to move from A to B. It's just if there's no problem, no non-object here, nothing happens. However, if you stand an obstacle, and the drone can send the obstacle, it will move to another direction. It's called collision avoidance. However, what happens if the drone cannot sense the obstacle? The collision didn't happen. And when the collision happens, the drone cannot keep flying. So it is another method to keep it recover from the collision and come back to work in normal. It's called collision impact reduction. And in the time of this keynote, I will focus on this topic, collision impact reduction. So let's talk about the problem. This is a structure of the drone. And a little bit additionally information for you. There are two kinds of drone. The quad plus is still quad plus and quad six. And okay, I will do not talk about the controller anymore. So when a collision is happening, there are three main scenarios can be happen. The obstacle can be collide with the drone body, and it can collide with drone propeller, or it can collide with the drone protector. So how researchers deal with this problem? Let's see. Here we have two main solutions. The first one is focused on the reduce physical impact. Here we use some protector, some resilient structure, and some portable propeller to deal with that. And the second one is use the recovery strategy after collision. So it focuses on the intelligence of the drone. Now let's go to the first one, the protector and the resilient structure. So the commercial propeller protector is very popular. Now you can see it appear in almost every UAV or drone, such as DJIs. There are some more solutions. Here is a origami inspired. Is have a donut shape and it's origami side, and this very innovative design have been published on site. And the last one is an insect-inspired structure. It means that when the drone is collide with obstacle, it will be deformed and reset and keep flying. It's still like an insect can jump and come back. So this is how people used to work with a protector and resilient structure. But now I want to focus on much and more interesting methods. Here is an example of how people code as cloud. So it's still like a balloon, and this balloon can touch and the collision fork. So it's quite interesting, and now it has been applied in some stadium to bring beer for the audience when they watch some match. And the next solution is focus on foldable propeller. It's not a rigid propeller. It's foldable. It means that it can be deformed on the vertical or the horizontal direction. And last one, this is I will do move faster. Is some current solution from some state-of-the-art methods that research have used, and I would like to focus to maybe I will ask for word about this strategy. Okay, you see, people try so many methods to improve the safety of drone. They equip the protector, they change the configuration of the propeller. However, when they do that, they increase the weight of the drone. That means they always stand a trade-off between the safety and the power efficiencies of the drone. That's really a question. Is it possible to significantly improve the safety of drone without compromising the basic design and function? And I want to focus on this to talk about very interesting solution. It's called tumble propeller. So this is a novel propeller which is not broken and still operate after a collision. Here, when we think about how nature deals with this collision problem, we look at how a nature animal, flying animal, deal with that. We look to the pigeon, we look at the bird, and we stop by the dragonfly. It's an insect. What is the advantages of dragonfly? So, how the teeth insect wing here can deal with the collision. And when we see more of the structure of the dragonfly, we found that there is a special structure on the dragonfly wing called nodes. The nodes work as a soft joist. We can help the wing can be fold and release, fold and release. So, you can see here. Okay, it is a nodes, so it can explain how the insect can, when you fold the wing of the dragonfly and you release, it can keep flying without any damage. So, with this idea, we bring it to our structure to create a novel propeller. We call it as tumble. And this one here is nodded. Just we copy exactly from the dragonfly. And now, this is the structure of the tumble propeller. Here we use some soft material, and you can see here, it can collide and it can reshape. There's no problem. It's still working. But it is a very simple demonstration. We don't know how the drone keep working with four foldable propeller like this. So I need to focus on more investigation. Here we use an aluminum frame, and we touch very hard, but propeller they are not broken. It still works after that. And after we develop the collision reaction strategy, you see, if the collision happen, if we do not touch into the controller of the drone, it still fall. But when we implement a collision strategy, the drones can collide, fall, recover, and keep flying. So I hope that it can contribute to the future of the drone. Now, yes, but it raises a question. That is the chain of alloy. So what is alloy? Let me explain in the short direction. Alloy, when you see some flying obstacle like airplane, drone, and windshield mill, although they have different size and shape, but when you cut the wing, the fixed wing, rotated wing, proactive propeller, and passive blade, if you cut that, you will find they share the same element. It's called the alloy. And when the drone works, the alloy will face to the wind and just create the properties of the propeller. So here's Mui. That explains how they can work in the real life. That's raise a question. The question here is that with the tumble structure, we need a very huge alloy, which reduce the which increase the energy consumption of the drone. It is how can I say? It is a normal alloy, but here is our desired alloy. So that chain that make a next question about how we can deal in the future. Okay, so let it for the future. I do not talk it now. I don't have a current solution for that. Okay, so let's talk about the challenge and future of safety collision. So three main current point here stand here. First, the trade-off between the safety and the power efficiency. The second one is a complexity of production of the kind of deformable propeller. And the three is lack of propeller crash sensing. Although the propeller is crashed with the object, but we don't know exactly when did it crash, so we cannot trigger the recovery strategy. That leads to some novel idea, and now I am on researching on this. This is an idea of another thing that I call turbo hub. This turbo hub can detect the collision and can reduce the fall. And until now, I have created this hub can work with almost every normal propeller. The thing here is that you can use a normal propeller with this hub. So it means that you can buy a commercial propeller and use my hub to work. So what is the benefits of my hub we bring? The first thing is that this hub can reduce more than about 30 to 40 the collision fault. It reduces 30 and 40 collision fault. It means that after several collisions, this propeller can still work. And secondly, it can reduce fast forward after the collision. It means that the drone can keep recovery very fast. It is the advantages of this hub. And now it is under a patent processing. So I'm sorry that I cannot talk more detail about the structure of this hub. And when I think about this, a next solution we would think that I completely implement this hub into an ordinary propeller with minimal design. So it means that now you have the propeller with exactly what we buy on the website. However, when the collision happens, it reduces 40 to 50 collision faults. It increases much more the safety of the drone. But you know, when a propeller is broken, it means that the whole of the drone will be fall down and it can make a lot of problem. And it's still under the patent too. So everything is the future. Okay. So if we talk about the future of collision safety, I think that in the next future, we will establish a novel concept of a soft drone. A soft drone that a drone can be deformed, and how of the drone can be deformed after a collision and recovery. And the next this novel structure and recovery control strategy will for UAV will be developed in the future. Just maybe the future collision of safety UAV, as I think. Thank you so much for your time. And once again, I would like to thank you so much for staying here on this time. Thank you.